Hello everyone. Now again we are here today. Our next topic of the class 11th physics, then your work, energy and power. This one unit is going on. So in last class we discussed about their potential energy and gravitation potential energy is discussed. So as body is falling down due to the effect of the acceleration due to gravity, you can say under the effect of the gravity of our earth and body is moving down. So under this one effect, then gravitation potential energy will be there. Then yesterday we solved that is equal to mgh. Okay. So two type of energy we discussed already: kinetic energy and potential energy. Kinetic energy half mv square and potential energy mgh by using your calculus method, derivation and differentiation. Now again our next topic for our the potential energy of the spring. So all type of the form of the energy we are converting into two form: kinetic energy and the potential energy only. So this one your elastic, you can say elastic potential energy, spring potential energy. When we are compressing and you are elongating spring, then during that case energy is the conserved in form of the spring, that is known as the spring potential energy. Okay, जो spring जो energy store करता है बेटा, that is form of the potential energy. किस टाइप की energy होती है? Potential energy. ठीक है, gravitation energy कैसी होती है? Potential energy. Clear? So here we will discuss this one, potential energy. Now if we are taking there any spring, then initial position of this spring is this one. Clear? Initial जो actual position spring की क्या है? This one. If its length we are taking its length, let there is a L length of this one. Now XL whatever you can take there, this one your change in the length. So this one our spring. Spring की क्या है? Original length है. So as we are compressing it, compress कर रहे हैं या elongate कर रहे हैं, then their force will be act there. That force in the spring we will call it restoring force. So before this energy we will discuss about their force, that is a restoring force. Now here energy is stored until force is removed, then object spring come back to its original position doing work in this process. जैसे ये आपका spring है, spring को अगर आप elongate करोगे, as we are elongating this one spring in this one direction, elongate करके क्या कर दिया? ऐसे कर दिया. Then here some change in the length. Okay, then this one length let we are taking there del x. Okay, if there is small length del x, then total length if we are taking x only, then here after this one remove this one. ये कह रहा है कि remove this one force, then object spring back to its original position. जैसे इसको रिमूव करोगे, इसको elongate किया बेटा, फोर्स इस तरफ, अप्लाइड फोर्स क्या था हमारा? इस तरफ लगा. Then as it will be come back, this one your force applied. तो जैसे इस अप्लाइड फोर्स को हम रिमूव करते हैं, then what happens? स्प्रिंग क्या करेगा? वापस आ जाएगा. स्प्रिंग जनरल सा क्या होता है स्प्रिंग के अंदर कि एनी स्प्रिंग वी आर टेकिंग, उसको स्ट्रेच करो, लंबा होगा. जैसे इसको रिमूव करोगे एक्सटर्नल फोर्स को, then it will be come back its original position. It regain its original position. तो वापस आ जाएगा. As this one coming back in its original position, then during this one which one energy is stored in that spring, that energy is known as the elastic energy of the spring, you can say potential energy of the spring. So the deformation could involve then compressing, stretching and twisting the object. Compress करना, उसको elongate करना, that energy will be act there, that is known as the potential energy of the spring. Okay, जैसे अगर इसको क्या करोगे? compress करोगे, then its length will be changed, it will be decreased from the original length. Clear? कि original length से कितना change आएगा? This one our original length. क्लियर? तो इतना इंक्रीज स्ट्रेस किया, फोर्स अप्लाई किया, इधर की तरफ चलेगी तो चेंज इन लेंथ ही हो गया बेटा. एज वी आर कंप्रेसिंग दिस वन, कंप्रेस करने के लिए क्या किया? फोर्स इधर अप्लाई किया, तो ये अप्लाइड फोर्स है. बट एज वी रिमूव दिस वन फोर्स, देन इट विल बी गो बैक ऑन द ओरिजिनल पोजीशन. सो चेंज इन द लेंथ वी कैन राइट देयर एक्स इज अ चेंज इन द लेंथ. तो वापस आने के लिए जो फोर्स लगा, दैट फोर्स इज नोन एज द रिस्टोरिंग फोर्स. सो फर्स्ट आई एम टेलिंग यू रिस्टोरिंग फोर्स. Restoring force. Clear? We can write there this one. The force acting in the spring, okay, which is acting as you remove this external force, then it will regain its original position. Due to this one, that force is directly proportional to the change in our, this one force is equal to our change in the length, how much change in the length is take place, and remove this proportional sign, then here we will take a k constant that we can write there spring constant. And see beta, this one change in the length is the opposite direction of our restoring force, that's why here this one component we will take there negative. Okay, force and your change in the length both are in opposite direction, that's why here negative. कि हमने फोर्स इधर अप्लाई किया तो इलोंगेशन डायरेक्शन में चेंज इधर आ रहा है, तो ये फोर्स किधर लग रहा है, जो इसको वापस लेके आएगा ओरिजिनल पोजीशन में। चेंज इन लेंथ के अपोजिट हमेशा क्या लगेगा, रिस्टोरिंग फोर्स लगता है, जिसकी वजह से हम क्या कहेंगे, दिस वन विल बी आवर नेगेटिव। ओके, सो इन दैट केस योर के इज आवर कांस्टेंट एंड दिस वन के इज नोन एज द स्प्रिंग कांस्टेंट या रिस्टोरिंग फोर्स कांस्टेंट। ओके, के इज आवर स्प्रिंग कांस्टेंट, यू कैन से K. Okay, so spring constant you can say K equal to your F by X. Understood? Okay, now according to this one force we can define there one law also beta, that is known as the Hooke's law. What? Hooke's law. क्लियर, इस फोर्स पे ही डिपेंड है कि अगर हम स्प्रिंग लेके चल रहे हैं, दिस वन आवर ओरिजिनल स्प्रिंग, डाउन एज वी आर अप्लाइंग दिस वन, ये कैसा स्प्रिंग है बेटा, ओरिजिनल स्प्रिंग है आपका, तो ओरिजिनल स्प्रिंग के ऊपर क्या हमने फोर्स लगाया, force we are applying in this one direction, that is applied force we are there, then what happened, its position will be changed, it will be shift here. Okay, that is your elongated length. Okay, which one length? Elongated length. After the elongation, that its length will be there, x change will be there. Okay, so as we remove this applied force, then it will regain again its original position. So जैसे इसको original position के लाने के लिए this force we are not applying, सिर्फ हम उसको remove कर रहे हैं, remove करने के लिए जैसे ही वापस shift होगा, तो during this one time that force will be act on the spring, that is known as a restoring force. So according to this law, according to this law, according to this law, then we can say that force, restoring force, is directly proportional to the change in the length. Okay, so this one change will be equal to your constant, as you remove this proportional sign equal to, then it will be constant, and here will be your negative sign only, negative because of your negative due to opposite direction. What? Opposite direction of F and X. Okay, F is our restoring force, X is our change in the length. दोनों क्या है, opposite direction में लग रहे हैं, that's why here will be your negative. So here we can write there this one elongated length and K will be our spring constant. This one force is, this one law is explained with help of the hooks. Okay, so F and R both we can see your force and displacement both are acting directly proportional to our each other. Okay, but in the opposite direction, that's why here beta we will remove this one our negative, this one. Okay, opposite. So as we are using this one beta, here we are solving this one potential energy of the spring. So this one force I hope you understood beta when will be act there. So in the spring case that for restoring force will be act there. So here we want to find out energy how we can find there, spring potential energy, spring potential energy. How we can find this one, as we are taking this one spring only and apply their force, then changing the length, this one your x length will be their force applied in this direction, restoring force will be acted in this direction. So as x, let we are using there let x is elongation and length as some external force applied on it. Okay, so work done is small for small change in displacement. Okay, so here we will write there dw equal to beta fds. I told you beta any work, any type of the energy वो want to find out, then first we will find their work कि ये कितना काम कर रहा है, यहाँ से यहाँ तक elongate हुआ, तो जैसे ही रिमूव करेंगे फोर्स में तो it will be regain its original position. So coming back along this one, then how much energy will be stored by this one spring, that is known as the spring potential energy. Okay, तो store कितनी energy रहेगी depend upon the work done कि ये कितना work कर रही है again coming on the same position. So this work we will find there. So beta here force we know that about this one, as we know this force we will not use here F equal to ma. Keep in mind which one type of the force is acting to do that work, then which that force we will use there. Don't always there F equal to ma only. Here body is not accelerating. Spring ये नहीं कि यहाँ से उठा के इधर शिफ्ट कर दिया. Spring का one end क्या है? Fix. This one end is the fix. सिर्फ एक end को क्या कर रहे हैं हम? Elongate कर रहे हैं. Clear? So during this one, then which force will be active, that is known as the restoring force. So here will be equal to minus kx. Now put there in this one equation, then dw we can write there minus kx. Clear? Here will be beta dot. As you remove this one, then dot, then here we can write there fds cos theta. We are solving in each case actually this one here dot and remove this one dot product, then here we will write there cos theta. So theta is the angle between force and the displacement. So small change in the displacement in this direction, your force is acting in this direction, so here theta will be act there ds, then cos theta will be equal to your 180 degree. Okay, and cos 180 about this one, no, I think everyone, cos 180 क्या होता है आपका minus 1. So put this one value, then here we can write there minus kx dx here minus 1. Okay, small change in the displacement, then in form of your x we are using there, then here also we will use there x only. Your here from here x displacement, so small change in the displacement we are using there dx only, so here use your dx only. So minus minus this will be positive, then here left here dx dw, small change in the work done. For find out the total, then we will take there, for find out the total work done, take integration on both sides. Clear? dw equal to here kx dx, this one left only. Okay, so taking integration on both side, initially work done will be equal to 0, so our nothing change in our body, original 0 elongation, then total work done w, then elongation will be your x only. So your integration w, then here k is constant, you can write outside, then inside left your k dx 0 to x. So here integration, then we can write there x square by your 2. Okay, how we can take? 1 we will add in this power, 1 is there na, then 1 we will add in this power, then after the addition same we will write downside, so x square by 2, then here value 0 to x, so here we can write there 1 by 2 kx square. This one our total work done, that is stored in form of the spring potential energy. You can see that is your spring potential energy, that is equal to half kx square, where k is our spring constant, where k is our spring constant, and x is your change in length of spring. Clear? And that can be elongation, that can be elongated, can be compressive length. Okay, now next one, Now, next see beta this one question. The potential energy possessed by the spring is also known as, here options are there, elastic potential energy, extensive potential energy, compressive and deflection potential energy. Which one is the right option? ये कह रहा है कि जो spring जो energy रखता है poses. I told you beta different form of the energy having in two form, kinetic और potential. तो spring जो energy रखता है that is always potential energy. So this one here posed by the spring is also known as the elastic potential energy. This one is our right option. Okay, not your extensive, compressive and diffraction. So it will be elastic potential energy. This one will be right option. Next one question beta in our that given a spring of length is 1 meter has a two car connected to the both its length. Then two car move toward each other then such that spring is the compressed to the 0.5. Okay, one car is here, another car is there, then both are attached with this spring, A and B car. Here its length is given here 1 meter. क्या कह रहा है 1 मीटर लेंथ है. तो कह रहा है कि इट्स की लेंथ को क्या कर दिया गया, इन दोनों को एक दूसरे के पास लेके आ रहे हैं. द स्प्रिंग विल बी कंप्रेस. पास लेके आएंगे तो क्या करेगा, स्प्रिंग क्या करेगा, कंप्रेस करेगा. ऐसे कंप्रेस कर दिया. ए एंड बी बोथ आर ब्रिंगिंग नियर विद ईच अदर. तो चेंज इन लेंथ कंप्रेस कितना करने को कह रहा है 0.1 मीटर फ्रॉम द ओरिजिन. तो चेंज इन द लेंथ बेटा क्या आएगा, माइनस आवर चेंज इन द लेंथ वी कैन से दैट इट विल बी माइनस 0. Compressive minus will be there, extensive that it will be positive. So if the spring constant is equal to your 500 Newton per meter, then what is the elastic potential energy stored in it? So here given your spring constant in our question given already 500 Newton meter, then ये कह रहा है कि what is the elastic potential energy? We solved already. Elastic potential energy find करते कैसे, that it will be equal to your spring potential energy equal to 1 by 2 kx square. K is our spring constant and x will be change in the length. Okay, that change can be your positive, can be negative, can be your compressive, can be your extensive. So here compressing this one spring, so it will be minus 0.5 meter. We are putting here value 1 by 2, spring constant given here 500, then it will be your minus 0.5 square. So solve this one, then it will give us 250 into your 25 by your 100. Okay, now as we will solve this one, then it will give us 62.5, this one here joule only. 625, here 2 0, then here we will write 0, then it will be a joule only. Energy SI unit will joule only. So this one will be our energy that stored by this spring as we are taking this car coming near with each other. So which one is the right option here? C will be right option. That will be positive, negative, both are given, but during the compression then it will be positive, during the extension then it will become negative only. Okay, I hope beta you understood beta this one. Now next topic here, conservative and the non-conservative forces. Our forces we are dividing into two ways, conservative and the non-conservative. Some forces are conservative. Conservative forces beta in this one, your body does not depend upon the path, depend upon initial and final. तो work done भी कैसा होगा, work done अभी मैंने बताया work done किस पे depend करता है, force and change in the length, that is your work done. Okay, if we are using their vector form then you can use their dot product. So here this one work done आपका conservative nature होगा, non conservative this one is a depend upon your type of the force. All forces we are dividing into two type of the nature, conservative or non conservative. So those are coming in category, they are depends upon the path initial to final position as well as the depend upon the path, जिस path पे हम move कर रहे हो path कैसा है, then it will be non conservative, otherwise it will be conservative forces. Okay, for example here conservative nature and second one non conservative nature. तो अगर फोर्स आपका क्या रहेगा कंजर्वेटिव, तो वर्क डन भी क्या होगा कंजर्व वर्क डन होगा. फोर्स नॉन कंजर्वेटिव, देन वर्क डन also will be non conservative. So how you can identify it will be conservative or non conservative? Then energy stored until force is removed, then object spring come back to its original shape, then doing work in this process, that will be your conservative work done. Okay, so we are dividing all forces into nature. बेटा इसके अंदर तो क्या करता है, does not depend upon the path, does not depends upon the path, depend upon the only depends on initial and final position. But here non-conservative initial and final position. For example बेटा friction. ओके, फ्रिक्शन इज योर टाइप ऑफ फोर्स ओनली. अगर हम फ्रिक्शन लेके चलते हैं, फ्रिक्शन क्या करता है, फ्रिक्शन इज अ डिपेंड अपॉन योर बॉडी, योर कंडीशन ऑफ द एक्टिंग फ्रिक्शन ऑन एनी बॉडी, दैट सरफेस शुड बी रफ. फ्रिक्शन तभी लगता है जब सरफेस कैसी होती है, रफ. ओके, स्मूथ सरफेस पे फ्रिक्शन नहीं लगता. तो हमारा डिपेंड करता है बॉडी जिस सरफेस पे मूव कर रही है कि वो पाथ कैसा है, डिपेंड अपॉन द पाथ. Clear? Then motion of the body will be changed according to type of the path. So in that case, those forces in which motion of the body is depend upon the path, it is a rough or smooth surface, then those come in category of the non-conservative forces. Here friction is example of the non-conservative, जो depend करता है कि हम path कैसा ले रहे हैं. Second, conservative nature I told you बेटा does not depend upon the path, जो path पे depend नहीं करता. For example, gravitational force. Here if we are falling this one pen, then what happened, it will be fall down. But यहाँ बीच में नेचर कैसा है, इसका मीडियम कैसा, डिपेंड नहीं करता. ऑब्जेक्ट हमेशा कहाँ जाएगा, नीचे की तरफ ही जाएगा. बीच में अगर वाटर मीडियम भी है, एयर है, कैसा भी पाथ है आपका, बट इफ यू विल लीव इट, देन व्हाट हैपन, इट विल fall down only, does not depend upon the path. So in that case you can say gravitation force that come in category of the conservative notes. तो इस फोर्स के अकॉर्डिंग जितना भी वर्क डन होगा वो सब क्या होगा आपका कंजर्वेटिव. इस फोर्स के अलोंग जो भी आपका वर्क डन होगा दैट इज नॉन कंजर्वेटिव नेचर. अनदर एग्जांपल ऑफ दिस कंजर्वेटिव यू कैन से इलेक्ट्रोस्टैटिक फोर्स, मैग्नेटिक फोर्स, these are all are your conservative, does not depend upon the path. Okay, so in that case total work done in conservative force beta, total work done in closed path is equal to 0. कीप इन माइंड कि कंजर्वेटिव जो फोर्सेज होते हैं, कैसे फोर्स, कंजर्वेटिव जो फोर्स होते हैं उनके अंदर अगर हम वर्क डन फाइंड करेंगे, टोटल वर्क डन इन अ क्लोज पाथ, इट ऑलवेज विल बी इक्वल टू 0 ओनली. Okay, so in that case if you are finding their work done here, force and displacement graph you are taking, then here work done you are finding there, this one and this one. Here different way are there, A B C different way are there. Then here your force here acting there, if friction will be there, then depend upon the path. But if we are talking about the gravitation force, then during that case if you want to find out work done, then in all case your work done will be remain same only, because your initial and final position same, does not depend upon these path. path छोटा है या बड़ा है, कैसा है, डिपेंड नहीं करेगा. सिर्फ ये डिपेंड करेगा हमारा इनिशियल पॉइंट क्या, फाइनल पॉइंट का. Clear? I hope beta you understood difference between conservative and non-conservative forces. Okay. Then next topic here will be start beta power. Then this one topic we will discuss in next class. Then last one topic left of the power and the collision of the elastic bodies. Okay. Thank you for watching today.